It's a very busy time.
Oh, it is, yes. Okay. So good afternoon. Thank you for those of you who have made it live and some others of you who no doubt will be trying to catch up on this recording. So just a brief introduction about myself. My name is Mike. I work for Cyclone Technology at the moment. I'm a PLD facilitator. I live down in Dunedin. And this webinar today is actually brought to you by courtesy of Microsoft support, so they've helped pay for it. And I have a background in high school chemistry teaching, science, outdoor ed, but I've been in this role for a little while now, just helping facilitate the integration of digital technologies into a wide variety of school programs. And today is all about the chemistry edition, or the chemistry features in the education edition of Minecraft. So just to start with, because there's people with a variety of backgrounds here, I've pulled out some of the core achievement objectives from the curriculum, so I'm just going to go over some of the chemistry curriculum content very briefly. Then we're going to have a look through some of the key features. I'll show you how to use them, and then you can jump onto your Minecraft and have a go at that, because we're all science teachers or teaching science. We know that actually having a go ourselves is the best way of really understanding things. But first, just because there will be people with a little variety of backgrounds here, what I've done here is I've gone into the material world learning objectives here, and these three sort of paragraphy bits here are from levels 4, 5, and 6. Now, obviously, you can use this before and after that too. These are levels I thought were just kind of the most relevant in the centre. But by all means, if you want to use this in a primary school or with even senior chemistry for a little bit of revision or a break, please go ahead. There's lots of awesome things you could do with it. So the key ideas here, I put it in big bold green that I thought just this kind of links into the curriculum here is ideas about the particle nature of matter, the structure of atoms and of different elements, and then starting to distinguish between elements and compounds and atoms and molecules, and linking atomic structure to the organization of the table. These are all ideas I think you'll see soon that these chemistry features in Minecraft can link to. So the other thing I'll put there, these also in the material world objectives here under the chemistry and society heading. There's a lot here about the chemical and physical properties of a range of different materials and their technological uses or application in society. So actually how different materials are used, how different substances are used and what they're used for. And in Minecraft, we can create some really useful substances, items, using chemistry. We can actually create them from the elements up. And I think this is just a really neat, students are able to apply sort of some real life applications in Minecraft without them having to build sparklers in your classrooms, which, as much fun as it is creating more and more paperwork. So the other place where I thought this would be super helpful is many of us I know are often taught teaching not in a lab every period. And it's great to do something that's a bit more applied and practical, even when you don't have a lab. So that's where I really would have loved to have had this when I had a Year 9 class one year, last period, every Monday, upstairs in the hot maths classroom. It's a bit painful. This would have made life a lot easier. So these are just kind of a brief overview of the chemistry objectives where I think this is most applicable. And I've just pulled those off there. We're looking at the particle nature of matter, so elements, atomic structure, molecules and compounds, starting to move into stoichiometry. More this idea here that we have chemical reactions and they use a certain ratio of this element and this element to form this compound here. And reinforcing this can be super helpful because this is definitely something students struggle with a bit. But this actually links to if any of them have got past experience with Minecraft, we'll see as well. And properties and reactions. So this is just kind of a 30-second overview of the chemistry curriculum, mainly for the sake of anyone here who hasn't looked at that. So if some of these words and ideas are new, that is fine. I'm happy to answer questions later by email, or your colleagues at school or around you might be able to explain some of this a bit further too. But these are kind of the core areas where some of these features really tie into the curriculum, I thought. So inside Minecraft, students can actually create atoms. They can build them by adding protons, neutrons, and electrons. And then they can take those elements they've made and then form compounds from them, react different atoms together to form compounds. They can then react those compounds together to form fun and useful substances. Some of them reflect quite accurately on real-life chemistry. Some of them are a little more poetic license, but they're all quite good there. So they can also work backwards. They can reduce substances into its constituent elements. And that's quite a helpful idea too for students to be able to work backwards. And some of those representations are quite accurate. Some of them are reducing things that don't actually exist in real life. So there's, again, a little bit of poetic license, but there's a lot of really valid learning that can take place there. Finally, they can do really helpful things like floating cows on helium balloons up into the air, which is always good for student engagement and possibly has distracted a few of my colleagues and myself a little too much on occasions. So that's kind of just a real background, a brief introduction. This document here, I just wanted to highlight this now so that you're not panicking trying to remember everything. This is super easy to find on Google. I'll also send out a link to it after this. This is published by Microsoft. It's called the Chemistry Lab Journal, and it basically lists all the different reactions that you can undergo, the different things you might want to make, and the different elements or compounds you need to make those, and describe some of the things on here. So this is either a 30-second Google away, or I'll send the link out later. But it's a really useful document, and I'll come back to that a little bit later and have a look at that. But I just kind of wanted to put that out there at the start, that is there. So I'm going to hop over to Minecraft very shortly. And what I'll do is I'll show you, demonstrate live some of these features, how they work. And then in a few minutes, a little more than a few minutes, I'll stop talking and I'll get everyone that's online to have a go at this yourself. Come up with the questions, see what doesn't work. That's the best way to learn these things. It is much better if we can make these things a little bit interactive. So I'm just going to swap over here so that we can see my Minecraft game here. So if you haven't been in Minecraft before, this is the kind of screen you'll get when you've started up and logged in. And there's quite a few people asking me accounts too. So the Ministry of Education funds Microsoft Minecraft licenses for schools in New Zealand. So if you don't have this, if you already have a Microsoft login, it will probably work. If you don't, the cost for that license shouldn't be anything to your school, but you may need to pay your IT provider or bribe your IT provider at school to set that up for you. So there might be some cost associated with that, particularly if you're a Google school. But that should be largely a one-off cost. Or if you're a really little school and it just involves a little bit of manual work, it should be not too much work. Once you're in Minecraft, generally you'll want to hit play. And you can create a new world, which we won't do right now. You can join a world if you're having students host a world. You can view all your saved worlds. But what we're going to do today is view the library. And this is where there's a whole bunch of sort of pre-built worlds, lessons. Some of them are quite guided. And today we're going to look at subject kits. And then obviously science, finally chemistry. And we're going to use this one here called Chemistry Tutorial. Now, all these features here are available across Minecraft Education Edition, obviously provided that you're using a creative world. It's quite hard to get hold of these things if you're using a survival world. If you don't know what that means, don't panic. Just come and use one of these pre-made worlds or start a new one. So we're going to use a chemistry tutorial today because it's got everything laid out nicely for us and able to experiment a bit. Once you come in there, you could share a link with your students. So if you haven't done this before, this is where you get a nice link to put on Google Classroom or OneNote or Microsoft Teams, share it out to your students. But today we're just going to click Create a World. So once I've done that, while this loads up here, on the screen here, if you've used Minecraft before, you'll probably be familiar with something called the crafting table. This is basically a little table that the players can walk up to. They can right-click on it and they can use it to combine different items that they've collected together to build new things. So you can build, use wood and stone and make a stone axe. You can do more complicated things, so you can get wood and turn it into boards and then make bookshelves and get paper and ink from an octopus and make books. So this is obviously quite a sort of construction idea. So having some new tables here that actually let us build with elements and then compounds is a natural flow on from that, I think, which is really useful. A lot of students will have had experience with this, so it's we'll let them kind of make some links there with their prior knowledge. And there's 4 main new tables here we've got. The first one is called the element constructor, and this is actually for building atoms. I'll show you this one first in a minute. Then we've got the compound creator, which lets us take out atoms and turn them into compounds, so ionic compounds and molecular compounds. That's where all the recipes are that are in that lab book. That's when it's quite useful to know. Finally, there's a lab table, which lets you do a few more random experiments, create some quite fun things. And then that last one that I mentioned, the material reducer. So that's where we can get everything that's in our Minecraft world already and rip that back into its constituent atoms. So that's quite a neat way of working backwards. So we'll come to that one last today. I could equally see someone actually starting a unit with that too, starting with the realization that everything is made up of all these different special unique atoms. I'm going to work the other way today, but ooh. Okay. So I'm going to walk along here. A lot of these worlds have got all these signs explaining how to do things if you haven't seen this before. I'm just going to come up here today, and this is why we've used this world here. It's got all these things here, and come up to my element constructor. So once I right click on that, you'll see I'm met with this great big screen here. Hopefully this circle here is loosely familiar to some of us. This is sort of first electron shell. And over here, we can put in different quantities of protons, electrons, and neutrons. This area down the bottom here, where I'm just making all these squares go green, this is your inventory. So this is kind of your backpack, the things you're carrying around with you. So I can just start building my own atoms here. I can put in 1 proton, 1 electron, and I've made a hydrogen atom. And I can click this and drag this and put it into my backpack. For the chemists amongst here, you'll note I can put in neutrons. So the hydrogen atom has 3 isotopes. It has one with 0 neutrons, with 1 neutron, deuterium, and with 2 neutrons, tritium. So it recognizes these 3 different isotopes. It doesn't actually distinguish between them. It just calls them all hydrogen, which has got some positives and negatives. It does mean that your students aren't going to get confused, but it does actually recognize them. So any sort of, I haven't gone through and checked which ones they have, but loosely normal isotope it should recognize. So I'm going to build some other things here. So if I want to build magnesium, I can also just type in here. So I can just type in 12 protons, 12 electrons, not 1. I've got the magnesium isotope off the top of my head, so 13. So I can get some magnesium atoms. And you'll note here that we've got 2 electrons in this first shell, then 8, and then 2 more in this next one here. So it's automatically doing this electron arrangement for us. The only thing to keep in mind here is this uses 2, 8, and then 18. So if you are taught 2, 8, 8, 2, you're going to get some slightly confused students. But it's going to work perfectly up to 18. It just won't get you quite up those last 2, they're up to 20. Personally, I always like to teach my students that we tend to use the simplest model that we need at the time to try and alleviate some of that frustration they get when they go to the next year and it's a new model. The last one's wrong. Like, oh, no, it's not. It was just a simple one. So it does this electron arrangement for us, and you can build massive things here. I haven't checked exactly which they go up to, but you can build any of the lanthanides or the actinides. So I'm just going to, we can click these one at a time, or we can click up to something massive here. You can teach students here too that you can put in the same number of electrons as protons and then kind of just click around about here. I don't even know what 88 is. I better have a look. Radium, and that needs a whole lot more here. So we can go right up to here, radium somewhere. No, I can't bother doing that at the moment. So this is the element constructor. The only thing I've got here, my little sad face, there's no ions here. Possibly that's useful in a lot of classes that won't confuse the students with them, but you're not going to be able to use this to reinforce or teach that learning. But it does recognize the different isotopes, which is really good. So that is our element constructor, and we can use that to construct any elements. And these exist just as blocks here. So when I come out of here, I can start placing a magnesium block or a hydrogen block all over the place and just build with them, just like a normal Minecraft. That is our element constructor. So once we've built ourselves a whole lot of elements, we can come to, I'm just going to grab these out of here because I was feeling a bit lazy. In the tutorial, you'll find that the chest has got some examples already made. This table here is our compound creator. And in our compound creator, this is where we start to get that stoichiometry, those sort of semi-balanced reactions going. We need the right ratio of different elements to make new things. So I can add, and I'm here going to place these in here. If I left click, I'm going to put 64. And there's probably some silly organic compound with 64 hydrogens, but there's not any simple ones. So to put just one of these in here, we're going to need to right click, or if your students run a Chromebook, I believe that's either a 2-finger click, often on a Mac too, or hold down Alt and click. I can put one hydrogen in and right click to put one oxygen in, and there's nothing happening because I actually need my 2 hydrogens, so I'm going to right click a second time, and then I can get a beaker of water out, which is nice and handy. So I'm going to play with my magnesium and put an oxygen in, and I can now get some magnesium oxide. So there's a whole host of different compounds we can create this way, a bunch of molecular and a bunch of ionic compounds. I really like the fact that this requires you to put the correct ratio in. There's some examples here. This one wants me to make, we better try this one, what it says. So we're going to put 2 carbons. We're going to need 3 hydrogens, a sodium, 2 oxygens, and we're going to get our sodium acetate. There's a reason they've made us do this. So this is the compound creator. We're reacting our elements together to form compounds. We're not going into types of reactions. We're just adding the correct ratios, and then we get our compound out. I really love the fact that this is sort of the first and the concept behind a balanced reaction. We're not balancing the whole reaction to get the amount of product. We just get infinite product, but we're having to react the reactions together in the correct ratio to get our product. If you only got the right amount of products, it would students would spend a lot of time building them there. So this is our compound creator. So the first one here is this element constructor. That's where we just build atoms. Then we can take those atoms and react them together to form compounds. There are some molecular and some ionic compounds there. It doesn't really specify in the game the difference between those two, so that would obviously require further reinforcement in class. But lastly, here we can come to our lab table. And once we have compounds, there's several different places we can use them. We can use them in the crafting table, which I'll show you shortly, but we can also use them in the lab table here. So here we line up things along the top, and I'm going to put in 4 sodium acetates. And when I put something that's actually going to do something, the little tongs start moving along here. And we're going to combine 4 sodium acetates, and we'll go doof, and a nice sparkle thing in this. This weird little blue thing will appear, which if I go into my inventory with the E, shows up as an ice bomb. This is one of those ones which uses a little more poetic license. But if students get this now, I'm just going to run outside and throw this in water. It starts freezing the water. Students quite enjoy this, especially if you freeze a waterfall, it creates interest. So this creates sort of normal ice, hence the poetic license, which will eventually start to melt, but they can melt a whole lot of water with it. So those are our three kind of general new chemistry construction places. We can build elements, we can build compounds with those elements, combine them together for new compounds. And the lab table is one of the places that we can form new things. There are also, I'm just going to run down here. There are also normal crafting table. There are new recipes that we can do with these. So in here, I'm going to get some nice salts, some chloride salts, which make beautiful colors. And this shows you this recipe on the wall here. So we're going to put a stick on the bottom, a bunch of magnesium in the middle, and a nice chloride salt at the top. And we're going to get a colored sparkler. We can use different chloride salts to get different colors. When I get my colored sparkler, if I hold down right click, it will sort of light it, and then you'll see here I leave all these lovely blue sparkles in the sky. This looks especially neat in caves. You can wander around and generally have fun with that. So that's where we can use some of these elements and compounds in a traditional crafting table as well. So the lab table is just one of the places where you can use them. These are really neat. There's one of the other items that students can make is glow sticks, which I've seen lots of students like using as lightsabers, so they can run around caves having lightsaber battles. But obviously too, there's things here they can start making superphosphate fertilizer. They can make thermite. I think they call it heating stone or something. So some of these have actually got quite real life applications, particularly that superphosphate fertilizer. Works especially well in Minecraft. You can grow an instant tree by dumping it on the ground. But they start to have some real life implications there. So I've just shown you three things here. What I'd quite like you to do is to hop into Minecraft and have a go at some of those things yourself there. So I've put these instructions on the screen here. View library, subject kit, science, chemistry tutorial. Once you're in there, make and collect some of these things. So I've put the atomic mass and the atomic number there. So that's the mass is the number of protons plus the number of neutrons, for those who haven't come here before. So that just lets you figure out loosely how many neutrons to add to get some of these things. Make those in the element constructor. Hop down to that compound creator and have a go at making that chloride salt. Then you should be able to make your own sparkler. You can choose a color of your choice and have a go at that. Any questions, just sing out. So I will just stop talking for a few minutes and let you have a go at making some sparklers. As much fun as that would be to do in a typical school lab, there's considerably less health and safety paperwork to fill out to make it in Minecraft.
computer's a bit laggy. It's trying to do too many things. Our other science teacher here is called Irene, so we're having a good giggle that there's an Irene in there. And I've managed to make some ice. So
Oh, very good.
Oh, I'm sorry, Mike. I need some help in the compound creator.
Yes.
So I'm trying to make this cerium chloride. So I've got one cerium atom and two chloride atoms, and nothing's coming out the end. Is there
I believe you need 3 chloride atoms for that.
Okay. Oh yes. Yep.
And then it should work. That's right. That's why we're here.
And what's the trick with just picking up one atom from the pile? I've got 18 in a pile here.
Oh, so when you want to put one on, you just have to right click instead of left click, and that will just put one onto the wherever you're trying to place it. But then you just put the rest back where you had them, if that makes sense. So if you're on a Mac, you might be able to do a 2-finger tap on the keypad. It depends on exactly how your Mac is configured.
Yeah, there we go. Got it. So once you've got it in the right ratios, it'll automatically appear.
Yes.
Yeah. Okay. Cool.
Which is neat because it reinforces all that. A lot of learning there and doing that. And it prompts those questions from the students, which you can then answer and actually have discussions about.
Okay, I'm not a scientist, so I have a question about the elements. When you've
Yes.
got the magnesium one there and you've got the numbers 24 and 12, does that help me make it?
So that means that you want 12 of those P things, the protons.
Yeah.
And you want 12 electrons. And then you want 24 minus 12, so just 12 of the neutrons.
Why does it have to be so complicated? Why can't it just tell me? Is there a list somewhere that tells me how many I need?
So on the periodic table, you can get all those numbers. This is why chemistry teachers love this. If I was teaching you about that, I would have done it slightly in a bit more detail and slowly than a little box and a slide and a quick 2-minute explanation, obviously.
Yeah.
But these are
right.
numbers that chemists use all the time. So yeah, the
Okay.
top one minus the bottom one will give you the number of neutrons, basically.
Okay.
Oh, sorry, Mike. Another simple question. I've made my blue sparkler. How do I get the sparkles to happen? I'm holding it.
Oh,
Is it just
it's that right click button. Ooh. Just hop to the wrong slide
It's
just to
not used,
confuse
is it?
you.
Oh, you've just got a Mac mouse pad, so it is.
That is an interesting on the Mac mouse pad. I'm just going to take.
Yeah, it should be a control click to do a right click, but
If you just hold it down while you click, does that? Because you have to hold down that mouse button. So if you hold down control and click, does it start shaking it from side to side?
no. Maybe I just need to learn how to use my computer. Or get a mouse.
Let me up Google. Hold right click.
It's not use, is it? Because I'm looking at my keyboard and mouse settings.
It might be use, I think, yeah.
Oh, right. I just needed to hold it down a little bit longer.
Oh, yep. Working? Excellent.
Oh, good.
Oh, that's the point of this. And I learned too. And brilliant. So we've got 2 lots of sparklers. Ooh. And we have sorted the right clicking on a Mac. And so, yeah, did you hold down control and then hold down the mouse button? Sorry, Robin, you muted, I think, if you were talking to me. Okay, I'm going to move on in a moment. Hopefully that was making sense to you. It sounded like everyone produced some coloured sparklers and some ice bombs in the process, so well done. What I wanted to do now is take a little bit of a step back and start coming back to the curriculum at how some of these areas could start linking in here. And along the way, just show you a few extra things just to kind of prompt a bit more thinking there. So this is coming back, the ideas about the core concepts around the structures of atoms here. So we were building atoms Robin, the technology teacher, was learning about atomic numbers and atomic masses. That's the big numbers and the little numbers. We cover electron arrangement, so it arranges those electrons for you. I've just put a reminder there that it uses 2, 8, 18. It's kind of shells rather than the 2, 8, 8, 2 that is often used in that level of school in here. And finally, it starts to talk about, sorry, I have 2 keyboards here and I was using the wrong one. It starts to talk about arrangement of atoms on the periodic table. So in the same area here, if we come across here and down these steps here, I'm just flying. The other reason I like this is someone has beautifully arranged our giant periodic table for us. So it shows the different groups here in different colors, those atom blocks. So we can start to see how things are arranged there and start to see the similar properties. You can have students build the first 20 into a kind of condensed periodic table without all the transition metals in the middle there. So there's a lot of things you can do here with showing that and getting them to build them. If you've used Minecraft a lot, what I'm going to say now might make sense to you. If not, just don't panic. But it's actually quite easy to make a world where you have given the students an element creator so they can create those elements and create these blocks, but then save it in survival mode and have students load it in survival mode so they actually have to make their first 20 elements properly. They can't just cheat and get it from their inventory, and then arrange them into a sort of condensed periodic table. Take a photo of that, and they've done a whole lot of learning there in all of that there. So there's a lot of ideas here about the structure of atoms, and I really think it's super useful for that. It's one of its real strengths. We can move on to stoichiometry, this kind of reactions, making compounds. And that's that compound creator, putting the correct quantities of each element in. You could actually do ionic things there by making students work out the ion charges and therefore balancing the charges and making the ionic formula first. Then take that into Minecraft, make those chloride salts, make coloured glow sticks, make coloured sparklers. Lots of fun things to do there. So that is kind of ideas about the real big basics and beginning of stoichiometry there, balanced reactions, making compounds, taking those elements that they've made and putting those together. I've just called this area distinguishing because there's a whole lot of kind of core definitions here that we often are really important for students to get their head around and they struggle. And I find even I have to make sure I think carefully about it when I'm talking about it with other teachers as well. So this idea of an element, this atom that has a certain number of protons and a certain number of electrons and then neutrons. A compound that's got more than one thing mixed together. We can start talking about molecules. I've got a tick and a cross there because there's going to need to be a lot more additional teaching there. It doesn't super clearly display those to get a real clear idea. And I've sort of put a tick across next to ionic compound. It's not really strong for that. You can make them, but it really doesn't distinguish much unless you start talking about those charges to get what the formula is, how many chlorides you need for your ceriums. I think it does reasonably well looking at pure substances and mixtures. And the last thing that I promised I'd show you there, which I haven't yet, is that thing called the material reducer. Oh, I've done it again. So I'm going to come back up the stairs, all the way back up into here. And this is a really fun thing here. You can put any element, any block from Minecraft in here, and it will reduce it into its component elements. Supposedly determined by percentage. That's going to be loosely accurate. I don't think it's your 5DP analysis lab. They've put a note here that there's some blocks that obviously have to have some sort of poetic license here. So I'm going to take some lava, bucket of lava, and dump it in my material reducer. And it's going to tell me there's a whole lot of oxygen and silicon and aluminium and iron and calcium and a bit of sodium, a little bit of potassium, a little bit of magnesium. I'm not actually a geologist, but it sounds reasonable to me. If I take instead a water bucket, I have to empty everything out first. The most annoying thing about this is you can actually just chuck stuff off the side here if you want, and there'll be a huge pile of stuff. We get our bucket back. It's not an element. They just don't want to trash your bucket. When we put water in, we will get hydrogen and oxygen in accurate ratios this time. Absolutely. That's a nice simple one. Now bucket back. So we can take a grass block. You can start looking at all sorts of mixtures and every life things, but also you'll discover that your grass is largely carbon, oxygen, a bit more oxygen, nitrogen, and phosphorus. I'm not sure where our hydrogen's gone here. I assume there's actually some hydrogen in grass too, but that's what I said. This is loosely accurate. To be fair, it would probably give us so many hydrogens that we'd spend 20 minutes throwing them onto the ground, which wouldn't be very sensible. Block of quartz, so all the different stone types. Quartz here is obviously going to have a ton of silicon and oxygen. It is just silica, so that's going to be nice. And so we can actually get students exploring, and I'll show you where to find later. There's some great pre-made worlds here where they challenge students to go and collect items from around sort of the world, use the element reducer, and find items which all contain oxygen. Can't remember what it is off the top of my head. And then put each of those items in kind of a display cabinet on the wall. So they're going around learning about what elements are in different natural items. Pardon me, they can display work at the end of that. So that is quite neat there. So this is the material reducer, and that's the last of those kind of 4 new tables that this introduced. So this one is really quite good. So the last one here is there's something called soul sand, and that's where we get these unknown element, which is Minecraftesium for something that doesn't actually exist. Don't know what we're going to do with our unknown elements, so we'll just get rid of them. Obviously, if we put cerium chloride in, we'll just get cerium and chlorine back. So my impression of having a quick play with this is it is reasonably accurate. Most of the things you put in, the ratios and the things they say make sense. Obviously, they're going to make a lot of sense for just pure compounds, and things like grass and trees and wood, they're going to be reasonably accurate. But I think this is a really neat way of looking about the fact that everything's just comprised of these elements, and you can break those down and have a look at them. So I had that there under this kind of, there's my big pile of stuff. Distinguishing, and I think you could really start looking at pure substances and mixtures and have some good discussions about this too, about the fact that although your tree has this exact ratio, it's actually different for every tree. So that's, here we go. So my last thing here for chemistry and society is that there's a whole lot of these things here that you can make. Super fertilizer, super relevant. There's lots of discussion you could have around that. You can start all sorts of ethics discussions. Here in Dunedin, we have a fertilizer factory just down the road. It has to every sort of 5 or 10 years pay to replace all the nearby residents' glass because some of the fumes make it go milky. So there's lots of interesting things you can talk about. Fertilizer here. Chloride salts get used to colour things. They're used in fireworks. If you use around any New Year's or Guy Fawkes, you can talk about firework colours. Talk about that here. You might have a lab in school that you can demonstrate those. You might not, but you can still do them on here, which is really neat. You can make bleach. You can dye wool, coloured wool back to not coloured wool. You can make thermite, although they call it a heat block. I'm pretty sure that one's technically banned at schools, so you can do it in Minecraft instead. You can make helium balloons and attach them to cows and make them float up through the air, and you can actually make hardened glass. And there's lots of interesting discussions about that too. The chemistry they had in here looked loosely accurate to me. It obviously doesn't go much into the manufacturing process, but some of the chemicals in it look reasonably relevant to. So there's lots of these things here that you could build into kind of a research unit. Or if you're trying to integrate this into other teaching, you could have them designing a factory or a house or a building using some of these things and then just integrate the chemistry into that. So I think there's lots of neat things we can do here. We've got about 8 minutes left, so I'm going to run through these real quickly. I've got some general Minecraft hints here. If you haven't used Minecraft much before, the fantastic thing is it engages students. The problem is that unless you have a nice clear plan with directions, students get very easily distracted in it. So I've just put some sort of general hints here we give teachers all the time. We try and use a really clear plan from the get-go is really important. And if you have students in a shared world, my advice always to teachers is if they start wrecking each other's work, treat that like they reached over and grabbed their neighbour's book and ripped the page out and throw that away. And I tell students that beforehand too. They kind of get that idea and don't do that. And if there's someone that's just going to wreck everything, don't put them in a shared world. So you can, in Minecraft here, I'm going to push the wrong thing in, you can come into your inventory and you can get something called a camera. This is just a proof of work. And you can get something else called a book and a quill. So you can Google how to do this later if you want. I can take a photo with my camera and then I can come into my book and quill. Should be here. And I can put my photo in here and I can actually start writing about this is my photo and shows the electron arrangement. You can have students make all sorts of notes to show that they've done this, and then you can export this as a PDF afterwards. So there are ways of having students actually demonstrate their work and take that outside of Minecraft. They can just screenshot things, that they can do screencasting, record video. Particularly Chromebooks now have got a really great new built-in app for that. So there's a lot of ways of actually doing this. If you're new to Minecraft in general, keep an eye out. There's regularly courses about using it in teaching. So that's just some kind of general teaching hints. Then I put some more specific chemistry ones. Start simple so that you can have that nice clear task, and use the online resources, which I'm going to show you in the last few minutes, because there's all sorts of teachers who have created all these useful things here. So share pre-created worlds. So you can make worlds or you can find them on the internet and send those out to students, get them to use it. And there's all sorts of neat things you can do, like I was saying, about building this into the context of a bigger unit, integrating it with what's going on in social studies or in other classes here, looking at fertilizer, looking at farming, all sorts of things you could do there. So that is just my general hints. Now, in a moment, I'm going to pop out of Minecraft and we're going to look at the Minecraft website just to show you where to get some of these resources. Just before we get there, I really like this example. This is a lesson on there that has students building glass cubes and putting blue blocks within that to demonstrate the particle nature of the three states. So a smaller glass cube that doesn't fill in any direction, so a solid, liquid that's all filled the bottom of the giant glass cube, and then gas, they're evenly distributed in the whole bigger glass cube. So the students are building within Minecraft to demonstrate their understanding of this. But I am now going to pop out of here, come over to the browser. So there's three things I wanted to show you quite quickly here in the last couple of minutes before I see if there's any more questions. If you go to the Minecraft education site, really easy to find. I just Google Minecraft education and follow the link here. Up the top here is the link you're going to want. This is Teach with Minecraft. And then over here, there's this link called Explore Lessons. And this is kind of like a repository, a store of all these lessons that a whole bunch of teachers have uploaded. and not all of them, but a lot of them have got worlds that they've designed that students can download with them, or you can download and send to your students. So if you're doing this outside of science, have a look at those other ones too. They're great, but obviously we're going to start with science. And there's all sorts of collections here, but you can basically, I would type in what you're looking at here. So this is, I think, the one I was talking about earlier, an element scavenger hunt. And it has all sorts of information here, guiding ideas, student activities, tells you what they're going to get the students to do. This one here has a world here, so you can either download the world or open it in Minecraft. So that world will open up, you'll be able to share it with students. It's pre-made and designed, so it's got a board for them to display their items which have got different elements in them. So depending on what you're looking at, there's a lot of fantastic resources there. The last two things I wanted to show you is this chemistry lab journal. Again, I'll send out a link to this, but if you Google Minecraft chemistry journal, it's really easy to find. So this shows you, I'm just going to zoom in a bit here. All of these different elements here. So it's got the, and it shows you, gives you brief descriptions. It shows you all the craftable compounds. So this is all the different formula and the names of all the compounds you can make. So there's pages of those. And then it shows you the different things you can make on a lab table. So we can make our bleach, our heat block, our ice bombs, our super fertilizers, and then it shows you all the crafting table things. So we can make colored torches and glow sticks and hardened glass and balloons and sparklers and underwater TNT. The students will probably get excited about this one. Underwater torches, which is quite neat. And then you can go on and brew a whole lot of potions and potion stands. There's things you can do forever here. And this just talks about the material reducer. So that's the lab journal. It's mainly useful for all these recipes. Also, if you Google Minecraft elements, you can find this big table of, this is your recipe book you were after earlier, Robin, how many protons, neutrons, and electrons for each one, and the different isotopes of it that you can actually make. So as you can see, there's pages and pages and pages of these. Lots of isotopes of some of these. If you want that, you can get hold of that. Right. That takes us to 4:30. So thank you very much. I'm more than happy to answer any questions. Hopefully you found that whirlwind introduction helpful, and well done for actually giving it a go, because that is where we really learn. So yeah, any questions, let me know. I'll email this out as well, but if you could fill out that survey link when I email it out, that's super helpful. It helps us find out what's most helpful for you, improve these things, but it also means that Microsoft, to actually support and fund this, as they get that feedback, they'll keep funding it so we can keep running this. So thank you very much. Any questions, let me know.
I just have one basic question about the tutorial. When I exited the tutorial, it said save and exit. But what if I want to go back in and start from scratch?
That is a good question. Yep. I will hop on to my Minecraft. And I will show you on mine. So you can still start from scratch. So if you go back where we did at the start and into view library, subject, science, chemistry, if I click create world here, it will make a brand new one.
Okay.
And
Otherwise
yes,
it's in mine.
Yeah, and you probably will want to do that, because I tend to mess things up when I go and play with those. The other thing you'll find is that you have a lot of chemistry tutorials, like you notice I've got at least 4 here. So you can then go into these and manage and just delete them.
Okay. Cool. Thank
Because
you. That was
you'll-
very cool.
Oh, that is fine. I'm glad it was helpful.
I've printed out the lab journal to give to my daughter.
Oh, very good. Yes. No, the lab journal is quite helpful as a resource.
Yeah.
Brilliant. Hey, thank you very much. And any questions later too, feel free to email me. I'm doubly excited when I can combine chemistry in this.
Awesome. Thank you so much.
Right.
Thank you.
Thank you.